Any concept cannot be named a theory until it's proven directly. Unfortunately, I haven't heard of any tangible success. They drilled 24 wells in not 2017, 2019. The forecast is quite gloomy. Nothing much is going to happen. The investors at some point will get disappointed to the degree of pulling out, and it will be really, really sad because this will mean that the humanity will miss on a tremendous opportunity. Now that the world had woke up to it, to the reality, and all of a sudden everyone is talking about natural hydrogen.
Folks, meet Vitaly Vidavskiy. He's what happens when geoscientists look at our energy crisis and goes, "Have you checked underground?" While the rest of us were up here trying to split the water molecules, this guy has been studying how the Earth's been casually making hydrogen this whole time through something called serpentinization, which, yes, sounds like a rejected Harry Potter spell, but is actually just rocks and water doing their thing. And let me tell you, when rocks and water get together, they make hydrogen. But there's a kicker. This isn't just some science fair project. This could be the clean energy breakthrough we've been waiting for, assuming we can figure out how to get it without, you know, breaking the planet. Vitaly, welcome.
Thank you very much. Thank you for the introduction. Well, just to say a couple of words for the audience and for the
Yes.
sake of this interview, we don't really work with serpentinization. We believe we are the proponents of a deep-seated primordial hydrogen. Uh, from the concept we follow, it appears that hydrogen was preserved in the inner core in the form of hydrides, metal hydrides, at the stage of the Earth accretion, which happened, give or take, 4.5 billion years ago. And since then, hydrides forming the Earth core keep decomposing, emitting hydrogen outside the core through the mantle, through the crust, out into the space. So, in brief, this is what we believe in. We have the concept. It works absolutely perfect. It's proven through independent research around the world, through the lab, both fundamental and field research. And we are absolutely happy with this concept.
How much is your concept, say, more accurate than the other concepts that are used?
Absolutely the same, because every concept, any concept cannot be named a theory until it's proven directly multiple times by independent researchers. In geoscience, it is absolutely impossible to do so unless you have a time machine. Since nobody was there back then, down several hundred or several thousand kilometers below the surface, it's absolutely unproven. So these concepts, these hypotheses, they will never become theories. Okay, so from this viewpoint, our concept has exactly the same rights to exist as serpentinization and other concepts that are in the play with the modern, we call it mainstream academia.
So, for the context, let's go with who is Vitaly Vidavskiy and how actually did you start this natural hydrogen story?
Okay, born and raised in Moscow, Russia. Back then it was Soviet Union, apparently. And I joined the Moscow State University, the Department of Geology, in 1985. And this is when I first heard of natural hydrogen as a phenomenon. Okay, I'm not going to say I immediately started studying it, researching it, nothing like that. Being first year student, you don't think much about science, as you may imagine. You think about a bunch of other things. But my one of my friends, Nikolai Larin, he just happened to be my classmate for the entire university period. He invited me to attend the seminar ran by his father, Dr. Vladimir Larin. So in 1985, back in the Soviet era, there was not so much entertainment, so I happily agreed. Honestly, I understood little from that seminar, but then through the years, well, we've been friends with Nikolai since then, and through the years, I've been on and off. So in 2005, I came back from Australia, where my contract was finished, back to Moscow, and Nikolai invited me to work pro bono for his father group because they just were about to start commercializing the concept his father formalized in 1968. So
Wow.
when someone says that nobody knows nothing about natural hydrogen, this is not true. Okay. Some people keep working on it, on the concept, on the subject, on natural hydrogen as a substance for decades and decades. Okay. So I joined them. I spent 5 happy years working mostly pro bono. Not mostly, it was 100% pro bono, free of charge, as an executive director with a company named Lambinord Marketing Ltd. We just bought the company just as a vehicle, because back then it was way too early for anything about hydrogen at all, not just about natural hydrogen, but any type of hydrogen. So we spent 5 happy years together. I assisted them with a number of things. We performed 2 seasons of electromagnetic data acquisition in one Mediterranean country. Got wonderful results, but then obviously ran out of money. The investor said, it's time up. Sorry, guys,
Yeah.
that's enough." And then I had to leave them because I was offered a position with the one major oil and gas servicing company, because the bulk of my career was spent with oil and gas servicing, very much upstream in drilling and completions, and well servicing. Okay, workovers. So in 2020, I was sitting in lockdown in COVID, due to COVID events, and Nikolai called me. Well, we've been discussing the things back and forth through the years, but in 2020, he called me and asked me, "Do you have a lot to do?" I said, "Not really." I was in Cyprus, sitting at the villa, and he asked me, "Well, we are thinking of translating my father's book into English. Can you help?" I said, "Yes." 3 months, wonderful time. The whole world was shut down. I was absolutely busy like never. So, wow, I can imagine. And probably one of the best periods in my life. And I decided to come back because I left the oil and gas path altogether by then. And since then, I returned to Australia in 2021, established this Avalio entity, and now we are business partners with Nikolai 50-50 in this Avalio Pty Ltd. So among other things, we work here in Australia, and we work on a number of other projects around the world. So the most recent job was done for the company named Max Power Mining Incorporated,
Mhm.
a publicly listed company in the United States and in Canada. And we performed the desktop study for them for the state of Texas, believe me or not.
Okay.
So as an example, it took us about 3 months, almost 24/7, because it's a huge territory and plenty of data to analyze, as you may imagine.
So they had a very interesting announcement. And can you comment on that one?
Which one? Sorry, maybe I missed something.
I think a few months ago in Canada, they announced a finding of natural hydrogen.
Not if you mean that they joined the forces with the company named Chapman Petroleum, if my memory serves,
Yeah.
based in Calgary. to acquire some acreage in Saskatchewan, not even in Alberta.
Yeah,
And
Saskatchewan.
yes, mostly grouping around the historic wells where hydrogen has shown in the past. So I haven't heard a lot about this project yet since then. So they are probably conducting the soil gas survey. I can imagine after they perform this desktop study, because this is the usual way that things are done in the modern natural hydrogen industry, if you can call it industry, of course.
Yeah. So there are so many questions regarding this is so nascent industry and uh, what's actually happening. A lot of companies are doing something, but is there any significant finding after Mali?
No, well, there was. Problem is that Mali and everything before it, and until recently, all the finds are finds. They're not discoveries. You probably know the difference. The
Yeah,
discoveries are made intentionally on the plan, and as a result of conscious, systematic
effort.
efforts. All right. Yeah, the find is something accidental, ad hoc. So Mali was an accidental find. The well was drilled in 1987 by the local community looking for water. Someone smoked around the well. You know the story. Why should
Yeah,
I repeat? So it was a pure accident, and the best part of this Mali story is that the local entrepreneur, Mr. Diallo, came over, acquired all the acreage around this area, and he found the resource, and he found the courage to dive into this story without too much history before it. So I adore this gentleman, but since then there was no success there when they started making those
yeah,
systematic efforts. Unfortunately, I haven't heard of any tangible success. They drilled 24 wells in not 2017, 2019. The wells were 100 meters to 1500 meters deep, with no commercial flow from any well except for the original one, Bugu one,
yeah,
which is flowing till today and will be flowing for many years to come, because this perfectly confirmed by our concept, the concept we use. And there are several other bits and pieces around it. For example, about it. For example, the flow rates remain the same. However, microscopic the reservoir is and very shallow, 110 meters, but it keeps producing at 1,500 cubic meters per day, nonetheless, for 12 years, almost 12 years. And on top of that, cherry on the cake, the pressure keeps growing. The pressure was low from the beginning, 4.5 bar, and now it's 5 bar. Well, 10% up, once again, out from nowhere. So for oil and gas fault, this is a complete nonsense. No one can explain it, and no one really is attempting to. Our concept explains this perfectly. So to start with, um, about 5 years ago, the world started waking up to the natural hydrogen phenomena, and several alternative concepts emerged. So the mainstream is currently following what you just announced at the beginning: serpentinization. Well, we call them geochemical processes in the crust, because there are several others. To the date, there are about 2 dozen of them,
mm,
mostly in the crust. There is pyrolysis, there is radiolysis, there is hydrolysis, and other olyses, which we don't really care much for, because we accept the fact that these processes may be taking place in the crust. There are several problems. One of them is the very narrow operational windows, PT conditions, geochemical balances and equations, pH balances, different agents coming into play from different sides anytime, because in geology, nothing is fixed in place. Everything changes slowly but steadily. And number two, the biggest problem is quantities.
Yeah.
The structures allegedly emitting hydrogen, generating hydrogen through those geochemical processes, separatization of olivines, um, chloratization of biotides and the granites, and so forth. There are several, mostly going around oxidation of iron 2 into iron 3, not reduction, oxidation. And the problem is that these structures, they exist for so long, millions and millions of years. But if you try to calculate physically from the degassing rate on the surface, it's really easy. It's no brainer. If you try to calculate the volumes of hydrogen emitting every year, you will inevitably arrive to the conclusion that these structures would have been depleted, exhausted completely many million years ago. So forget about emitting now. They would be exhausted a long time ago and just sitting there, really turned into clays. Okay,
Yeah.
no, they don't. They don't. They still exist, and the people who enter this quantification subject, they either back up and say, okay, or maybe we'll get there later, get to it later, or they openly admit. I spoke to my PhD supervisor today, and he is writing a book, and I'm writing one chapter for him. So his chapter is about this very thing, separatization, and he uh, confessed the math doesn't seem to be working. So, I mean, we knew it from the beginning. People want to play with it. Okay, fine. People, academia, they get grants for it. So wonderful. They have something to do. We do practical things. For us, theoretical part was over a long time ago. While the rest of the world was sleeping and basically denying the natural hydrogen altogether for several decades. Oh, it's impossible. Why? Well, because it's impossible. No why, as we say here, Australia wide. Um,
Yeah.
we've been doing our research. Now that the world had woke up to it, to the reality, and all of a sudden everyone is talking about natural hydrogen. You check the mass media, Forbes and the CNN and all those big media. They start talking about natural hydrogen. We're done. We have our concept proven, like I said earlier, through numerous lab experiments, fundamental, highly technical, diamond anvils, high pressure, high temperature, 13, 15 gigapascals, basically the center of the Earth, simulated in those labs. And they arrived to the same conclusion. The core is combined by hydrides. The Japanese researchers are extremely proficient with this type.
So, where is this practically today? So, say in percentages, how close are we to say discovery actually? Because now we are doing it intentionally.
This close, a whisk close. We are, not we, the general we,
Mhm.
uh, we as a group, as a value, we are a whisk close. The only thing we lack is, well, sorry, money. So money talks, as they say, and we are looking for the investor to continue in several directions. We are prepared to work in any jurisdiction wherever the investor is comfortable to work at. We propose a very simple scenario. We have the exploration strategy for natural hydrogen. So we just follow, and it's really a strategy with the exit points, with the added value at every step. So the project could be exited with profit at every step, every milestone. And for the beginning, we don't really require a big amount of money. So it's compared to what other companies spend these days, those are peanuts. And
Basically, there's a huge technical gap in actually getting this hydrogen out of the earth. And what's up with the technology for this?
Well, getting it out from the earth is not so difficult because what we suggested about 20, Dr. Larin suggested about 20, 25 years ago, and what the vast majority of the companies involved with natural hydrogen are doing these days, drilling. So we as a humanity, we have the benefit of oil and gas industry, petroleum industry, and all the technologies, drilling, completions, production enhancement, workovers, etc., developed through the decades. Lots of money invested in the drilling, in the extraction part. But before then, if we go upstream from here, from drilling, we have this exploration part, which is tricky. And here, the trickiest part is that, well, it's really a mindset. It's really a comfort zone. So we're talking more about psychology, not about technology here, because the vast majority of the companies, including those flush with funds, and you know whom I'm talking about. Um, Everybody knows these names. Um, they follow the same algorithms adopted many years ago, many decades ago for oil and gas. But hydrogen is different. And this is where the gap is. Exploration, which needs to be conducted differently from oil and gas. Okay. So this is what we suggest. We suggest several exploration techniques. We developed some of them, like this soil gas detection was first invented by the Larin's group in 2007. We have the proofs. We have the website, and we have the pictures dated back then. Dr. Larin himself drilling and punching the first holes in the ground down there in Russia. And we have geophysical methods, which are time proven, which are absolutely tuned up. We can use seismic, believe me or not, but different type of seismic. Okay, because the conventional seismic, just to explain it in a bit more detail, conventional seismic was developed for um, sublateral, semilateral reflectors, they call them. Okay, dome structures and monocline layers of rock. So the seismic signal, goes down, reflects, and then read by the geophone on the surface. And so this is how the picture is obtained. So hydrogen, in our opinion, towards the surface through the vertical chimneys, we call them chimneys or conduits. So conventional seismic is not going to see those chimneys. So we need something else. So we came across the algorithm allowing to restack and interpret the signal taken from the raw data array to obtain this vertical conduit, well, picture or mathematical model. For us, it doesn't really matter, because with the soil gas surveys and soil samples for gas chromatography, which we started doing recently, we get the anomalies on the surface, but it's 2D only. So the best we can do is to identify the spot or several spots on the ground, on the map. Then we send the geophysicists there, and they identify the whole structure in 3D. And at the end of this phase, geophysical phase, we obtain A, mathematical model, and B, 3D coordinates, two latitude, longitude, two coordinates on the surface, and the depth, which is, of course, approximate. It's not as specific, as accurate as latitude and longitude on the surface, but it's specific enough to pick up the rig type, the BOP stack, to develop the well design, to start lining up the contractors, and basically to start to spot the well, to start drilling it. So this is the plan, and in this well, I know it doesn't sound real modest and humble, but we are the leaders in this, because nobody else has this strategy. That's number one. The best that the companies have who got money, who got funding these days, the best they can do, they drill. And without the robust and justified concept, this drilling is nicknamed as random drilling. Sorry. uh, Whatever the theories are, whatever the concepts are, and well, we can laugh, but the lack of result achieved or not achieved by those companies is a proof. Uh,
Yeah.
I'm not going to say that they don't know what they're doing. No, 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 sir. No. What I'm trying to say is that they keep trying the same concepts they adopted from the very beginning over and over again with the same exactly the same result.
I know
Negative.
one saying,
Ne-
I know one quote about that, but I will not say it. So, but
If you want to change something, if you want something to change, you have to change something. That's the quote. Okay.
yeah, that
So
that there's the other side. It's a definition of insanity, doing the same thing, expecting different results. And I think that, you know, so many companies are doing this, and nobody still has tangible results. Can you comment on that? So there's already, say, 50-ish companies
last
drilling.
count 60. Last count 60.
Yeah. So
Yes. Mhm.
60 companies drilling randomly, and nobody has results. What's happening?
They keep looking for the reservoirs. They keep looking for the deposits. Everyone is talking about the deposits. Everyone is talking about the holy trinity, the way it is in adopted in oil and gas, which is kerogen, generation,
Hmm.
migration, trap, deposit. Okay, so let's imagine that the hydrogen is there is generation down in the core. What can you do about it? Nothing really. You can find it. Well, it's there, and it's difficult to prove it. The third part, the trap or the deposit. Um, how do you name it? Oxymoron, something that doesn't exist, but everyone is discussing
Yeah, yeah.
it. What's the proper term for it? Because and this is the answer to a question. There is no success because they're looking for those traps, deposits, reservoirs, whatever you call it. Hydrogen is too volatile and too chemically aggressive to form the pressurized deposits. Okay, period. If you compare here on the day surface, what is the biggest nightmare of the companies working with hydrogen as a material?
Yeah. Transport,
Embrittlement
storage,
and, and
embrittlement,
that's right,
permeation. Do you
embrittlement.
want me to continue? Yeah.
Absolutely. So if hydrogen behaves, and these all these issues, all these problems are due to two virtues of hydrogen. Number one, it's very volatile, very mobile, and number two, it's chemical aggressive. It's a very strong chemical reducer. Okay, so whatever it touches, and it got the second smallest atom in the world. Helium is the smallest, 53, 53 A, and hydrogen is 56 or 57 angstrom. So, but helium is a noble gas. It doesn't react with anything. So
Yeah.
hydrogen reacts with everything. Everything it touches, it starts immediately reacting. So this happens on the surface. How come the things should be different down the hole? I mean, down there, down below the surface. Sorry, I'm talking as like an oil and gas person down the hole. um, all habits. My previous life. So exactly, except for those formations which are supposed to work as a cap rock for hydrogen, the way they work for methane and other hydrocarbons, they are penetrated, they are altered by hydrogen much easier than the special steel grades used by human beings on the surface for storing hydrogen in the pressurized vessels, for example, and so forth. So what are we left with? Migration, and here it is: chimneys, active dynamic systems. All right. So
Hmm.
if we recall the Mali case again, Dr. Omar Maiga, the member of the team of a hydromet team, published. He and his colleagues published the paper last year, 2023, stipulating stating nothing less that than, okay, guys, from our experience, vast experience with natural hydrogen well here in Mali, we can state that if someone is trying to attempt evaluation, the very touchy, very sensitive subject of evaluation of natural hydrogen resources in order to convert them into reserves, in order to develop the business model for it, it cannot be done without employing this dynamic model. If so, at least partially, maybe completely, maybe 100%. So we're not saying that this stationary model, gas in place, as they name it in oil and gas, it should be abandoned altogether. But even the very reputable companies in the oil and gas world, like RISC, the most prominent formation evaluators and reserve auditors, um, they reluctantly start admitting that this flux model, as they call it, has the right to exist. They openly stated it in Adelaide at the first Australian Natural Hydrogen Conference last week. There was a guy from the Perth office, and he said, "Yep, well, yep, it exists. We don't know a lot about it. He admitted openly that the community is still much more comfortable with the stationary gas in place model, so called, but the flux model, the dynamic model, it's there.
So
Dr.
the
Larin at his best." All right.
so the truth is that we don't know everything that we should know. Not near.
Well, we who is we once again? Sorry,
Globally.
sorry. Well, globally, it's not. We are indeed we're spread too thin, but not equally on the surface of the earth. All right. So I mean, and so is knowledge. Okay, some groups know more than others. I don't know much about astrophysics. Okay, I don't know much about nuclear fusion. I'm not trying to judge it, and express my unprofessional opinion, looking and sounding stupid. I don't want that. So, but we do know quite a lot about natural hydrogen, and we are prepared to share this knowledge. And I just mentioned this conference in Adelaide. You know what was the most frequent phrase pronounced there? Okay, we are looking for the business partners. We are looking for partnerships here.
Yeah.
Okay, even one of those biggest and best financed companies coming from the United States, and you know whom I'm talking about, they
Yeah.
said exactly the same. So okay, we're open for cooperation. We have. I'm not praying here. I'm not begging to trust me. Okay, our concept is better than others. No, sir. Well, first of all, we drill. Not we. I should be accurate here. My business partner, Nikolai Larin, drilled the first natural hydrogen well in the world in Nebraska in 2019 through the company which he is the co-founder of, named Natural Hydrogen Energy. Okay, registered in Denver, Colorado. I believe. Yeah, Denver, Colorado. So they drilled this well, and they have the. It was a technical success. Unfortunately, story of our lives, they ran out of money, and so they couldn't complete the technical program in order to finalize the case. But it was technical success. They encountered, they detected dozens of percent of hydrogen in the flow, in the flux. So
Okay.
this was a technical success. And once again, I keep talking about this concept because it's so beautiful. It explains a lot of things, and most importantly, it is predictive. So this allows us, what we do in the field, we simply implement it and adapt it to the field conditions. So we go there consciously and we find hydrogen, where we prognose it. Okay, it's not accidental. It's there.
Let's explain the cases that exist today. So Mali is more or less known to everyone, uh, but there's Chimera in Turkey, but there's something happening in Albania. There's something that was found. I couldn't reach the
45 8.
actual researchers, but I've seen that there was something found. Can you comment on these?
Okay. Chimera is the location in Turkey,
Yeah.
where hydrogen. Well, it's a mix. The mix of natural hydrogen and natural gas, methane mostly, keeps seeping through the cracks in the ground for centuries, if not millennia. Rumors have it that the first Olympic flames were ignited there a couple thousand years ago, but I wasn't there. Sorry, cannot comment on that. Anyway, I know I look old, but not that old. Anyway, this is probably the most ancient degassing sign of hydrogen degassing known to the humanity. But hydrogen is just part of the mix up to 11%. So it's not really significant. And you can see it from the color of the flames. They're mostly orange, bluish, like regular natural gas, mostly methane. So, but there is hydrogen, yes. Why they come together, it's a different story. Once again, we believe that hydrocarbons originate from hydrogen interaction with the carbon layers in the ground, down there in the rocks. But this is a different story. Okay, I don't want to poke
Okay.
into the beehive here. Okay, so speaking about this, the second one was Albania.
Yes.
Albania is one of those accidental. Well, it's not so accidental. The chromite mine was the ribbon was cut in the early 90s, so it's pretty old. So they mine the ore for chromium, and it's just a mining facility, and they always had the owners of the mine. They always had issues with like all miners do with combustible gas. Usually miners don't care a lot. They say it's methane, which is for the coal mines. This is true because
Hmm.
remember, hydrogen interacts with coal with
Yeah.
carbon. Here is your CH4. Okay, but in the chromite mine, the story is could be different. I'm not aware of the lithology and geology and petrology there, but anyway, the group of researchers from France traveled there a year ago, I believe, and they went down into the mine with all the proper authorizations, I believe, and they started measuring the bubbles coming out from the panels on the floor in the mine. And somehow, miraculously, they made the conclusion that there is such and such volume of hydrogen down below somewhere. So they collected several bubbles from the small pool on the floor, and then immediately they come up with a number. To me, it's more like, well, it's not science, it's like art or maybe something else. All right, I don't know what technique and algorithms they employed to do that. At any rate, it's not impossible because this albanian this chromite mine in Albania is situated on the megastructure called ophiolite. Denarides of light. It's very well known in the Adriatics on the eastern shore of the Adriatics, and there are several other locations which we study, not out of curiosity, to tell you the truth, where it is possible to detect hydrogen, but it's a bit too early to speak about that.
Knowing what you know today, What is your prediction for this industry?
Well, if the industry stays on the same track, yeah, everything pending everything we discussed in the first part, then the forecast is quite gloomy. Nothing much is going to happen. The investors at some point will get disappointed to the degree of pulling out, and it will be really, really sad because this will mean that the humanity will miss on a tremendous opportunity, absolutely unique opportunity to obtain eternal, carbon neutral, and very efficient resource, which is energy resource and chemical resource as well at the same time, which is which could be found in multiple environments, not just sedimentary basins like oil and gas. So this could possibly change if the industry, natural hydrogen industry, progresses. This could possibly change the entire geopolitical landscape the way we know it today. Some of the countries who are currently deprived of energy resources and have to import their energy, their um, energy carriers and chemicals, they could turn out to be much better position than today. And
There's
Mhm.
there's a lot of discouragement these days with so many hydrogen projects being canceled. And when I'm saying hydrogen, I mean like current hype about the electrolyzers and investments and so on. Could this affect the mood of investors in a natural hydrogen field?
Well, this story about so-called green hydrogen, I don't know who came up with this name, because we don't really support this color palette for
Yeah.
a colorless gas with no color, no smell, nothing. Um, well, um, I don't know what happened there because from the elementary molecular physics, which is taught in grade 6 or grade 7, I'm not sure, it is obvious that these projects were supposed to have negative EROI from the beginning. Problem is with with electrolyzers, the problem is that tearing the molecule of water apart requires exactly the same amount of energy that could be obtained through oxidation of hydrogen, which is the reverse process. Okay, so 33 kilowatt to generate 1 kilo of hydrogen from 9 kilos of water, 9 liters of pristine, fresh distilled water. Don't forget about desalination before it. And exactly the same amount of energy received in the opposite process. And everything in between is nothing but losses. Okay. So the ROI for the best, most efficient electrolysis process is 65%, less than one. So 35% will always be in the losses, and someone is supposed to pay for it.
Yeah.
Okay. So where is this money supposed to come from? Subsidies, right? This is what the modern entrepreneurs are counting upon. And at some point, the governments start scratching their heads and saying, how can we support those guys' profits, private companies' profits, with taxpayers' money? And then this is it. The business model for green hydrogen is not sustainable, not because it's bad, not because someone is scheming against it. Nothing. There is no conspiracy, sir. It's
Yeah.
just molecular physics, Mother Nature in the works. That's it. So, sorry, I don't know who checked the physics before investing billions of dollars into those projects, but probably it wasn't properly done. Once again, I wasn't there. I cannot comment on it. I can comment on the very objective things. You know, physics. It's science. It's nothing spectacular about it. These reactions are known for hundreds of years. So This is the answer about green hydrogen. With natural hydrogen, um, the story is different because it doesn't need to be synthesized or um, manufactured in any way. It keeps flowing through the surface of the planet for millions of years before the humanity emerged. After we all die, it will be flowing through the ground upwards and into the outer space for many, many million years to come. Okay, so all we have to do is to capture it, and that's it.
Yeah.
It well, it sounds simple, but
Sounds
this
simple,
is
yes.
yeah, really, exactly. It sounds simple. It's easier to say than to do, but this is all we have to do in an essence. So with ERY and carbon capture in regards to natural hydrogen, the industries, all industries, including oil and gas and other industries, have developed very robust and very reliable protocols for carbon capture, for emissions prevention, and so forth. Okay, CO2 may come as a associate in the gas mix with natural hydrogen. This is on the bad side. On the good side of things, there could be helium,
Hmm.
which is a great addition to the spreadsheet from financial viewpoint. So this is how the things are. Um, the problem with the well, it's not a problem. This specific feature of natural hydrogen is that we're dealing with subsurface, and there will always be the risks involved. Same way, the way it is with oil and gas, petroleum, with mining, with the geothermal, anything really, whatever commodity or resource you start thinking of, which is down below in the subsurface, it always involves the risk because we cannot see it or touch it physically with our hands until we drill there or mine it. Okay, so
So,
hence the risks. Mhm.
yeah. Uh, how long will the investor patience last? I'm saying, should we expect discovery in 2025 or at least one significant result anywhere in the world?
Well, there are some good signs demonstrating that the community slowly but is starting to turn their heads from the obvious failures to some alternative concepts like our concept or similar. I mentioned Mali and Dr. Omar Maiga's paper last year. Another example is QIMC, which stands for Quebec Innovative Metals Corporation. They are running Dog and Pony Show now. They are planning to go with IPO to float the company. And in the process, their CEO keeps talking about advecting streams of hydrogen, conveying it to the surface, which is exactly what we've been talking about for several decades. And um, he is my contact in the LinkedIn, and something tells me that he employs at least some bits and pieces from the concept we utilize in our research. So, and not surprisingly, his their QMC's soil gas survey results are extremely encouraging. So I'm not advertising here anyone. Okay, I'm just stating that those guys started tried to think differently, and they get different results, which are positively different from the vast majority. Okay,
Yeah.
so far it's just a surface data acquisition, so they are in the early days. But if they follow it, if they keep stay on this track, well, I would say I my expectations are quite optimistic about their project in Quebec. The others look for deposits, talk about serpentinization. Well, what can I say?
Okay, so let's dive deeper into the methodology. How do you assess reservoir permeability and seal integrity?
Question number one, yes. Well, first of all, there is no reservoirs. Okay, let's agree about that. So,
Okay.
seal integrity, gold hydrogen example in South Australia is probably the best one. They don't have the seal; they have hydrogen trapped in the fractured zones down below, several two or three zones in each well, and the wells are only 1,000 meters deep, quite shallow for oil and gas, but they don't have a proper seal. So from once again from oil and gas paradigm, from oil and gas perspective, it's impossible to produce from those wells. Okay, the wells they're drilling now, so they're looking for alternative solution. um, well, we'll see what happens. It depends on once again what concept, what model they employ. Because a lot of companies say, "Well, we don't really care where the stuff is coming from. Okay, subsidization or deep seated doesn't really matter. It makes no difference to us. We need it on the surface." Well, the problem is that the selection of concept of a concept governs the everything else, everything downstream from it. Okay, exploration and data acquisition campaign and the development model and so forth and so on. So like I said, gas in place model seems to be, well, compromised for natural hydrogen. Let's put it this way. At least there is no news about successful implementation of this concept. Well, we'll see what happens. 2025. Let's see what happens with QMC. Let's see what happens with us, Avario, and Natural Hydrogen Energy and Larin Engineering, our business partners in Europe. Let's see if other companies here in Australia or down there across in the United States start adopting alternative models. If not, they just, well, in my humble opinion, wasting their money, the money, the investors' money.
So you said there's no reservoirs. What is there?
Advecting flux, flows, chimneys, conduits, whatever you call them. Let's put it this way: the anisotropic irregularities in the crust, conveying hydrogen and other gases in the mix upwards towards the surface, due to several factors, physics.
S- So how do you model these potential migration pathways of hydrogen within complex geological structures?
Well, they've been modeled by Dr. Larin 20 or 30 years ago, if my memory serves. There is a number of papers published by Dr. Larin, his group, my business partner Nikolai Larin, in conjunction with other researchers and other researchers separately. For example, nuclear physicists who count neutrinos. You know, there is a domain in nuclear physics; they count neutrinos. There is a very prominent group who use Dr. Laren's concept in their business day in day out, and they confessed openly that they tried every other model, and only Laren's concept worked for them. So back to natural hydrogen, other researchers bump into it from time to time. They just don't see it. Okay, they refuse to admit the fact that, well, because it quite often contradicts the mainstream postulates, mainstream scientific concepts, and so forth, academia, beliefs, and so forth. So these chimneys bring hydrogen. It's, you know, about 10 years ago or maybe 15 years ago, there was a lot of buzz going around so-called bookmarks, which bookmarks are small um, spots on the ocean floor, on the ocean bottom, which appear as a result of degassing bubbles
Mm.
advecting from below through the silt and unconsolidated ocean deposits to the surface. So these phenomena exists, you know, and it's like bubbles in the streams in Oman, showing 82% of hydrogen in them. Once again, coming from the ophiolite structure in Oman, similar to Albania. Um, and these advecting, these vertical degassing structures are known for decades, if not centuries. Once again, there is nothing new about them. It's just the problem is to match this knowledge with the concept that hydrogen keeps degassing towards the surface through similar vertical subvertical structures going along the, we call it lithostatic pressure gradient drop, okay, towards the surface.
What specific geochemical markers do you rely on to determine between biogenic and thermogenic sources of natural hydrogen in subsurface formations?
Well, there are not so many geochemical markers. The isotopic signature study assays called delta D or delta H, depending on the researcher. It studies the ratio between protium, hydrogen with um, one neutron in the core, and deuterium. So deuterium is much heavier, of course. So protium evacuates the system first. So the protium enrichment means a very deep source originated from the mantle. The protium depleted, and it's measured in negative promille. Okay, so minus 700, minus 600. These values attributed to hydrogen detected in different parts of the world. This hydrogen probably most likely is of the deep mantle or core origin. Um, 200, 300, minus 200, minus 300 promille is most likely to be sitting in the crust for a while, or possibly formed in the crust as a result of geochemical processes. So this is the most reliable criteria, similar to helium 3 versus helium 4. Helium 3 is primordial, helium 4 is crustal, formed by through the process of nuclear decay, radiogenic helium. So apart from that, other associates like carbon 14, carbon 14 um, analysis, nuclear analysis, is the it's a good indication of organic versus inorganic, non-organic prominence of carbon. So we mostly concentrate on those flux structures working, and we work from bottom and up. We don't really concentrate on biogenic hydrogen.
Okay, interesting. How do variations in tectonic activity influence your assessment of hydrogen reservoir stability and back to the reservoirs, particularly in seismic active regions?
Once again, no
Let's say
reservoirs.
chimneys. Let's say
Yeah,
chimneys.
yeah. Chimneys may shift with time, so they are not frozen in the 3D subsurface space due to local tectonic or igneous activity, for example. But fortunately for us humans, it happens quite slowly on the geological time scale. Okay, therefore, natural hydrogen, is more than renewable; it is eternal on a human civilization time scale. But apart from that, we don't. Once again, everything works on, on a certain time scale. In our lifespan, we see some geomorphological structures emerging on the surface, like those famous circular depressions. Someone gave them this improper name of Freire circles, which is absolutely, we don't really use this term. I just bring it up so you know what we're talking about. Some of them emerge on the memory of one generation, 30, 40 years, from nothing to a small depression. Then the water starts accumulating at the bottom, And surprisingly, initially the water is fresh.
Yeah.
So distilled water, okay, where hydrogen meets oxygen, all right, and then it becomes salty, of course, because of the certain processes in the aquifers and overall in the upper soil layers. So this is a good example, but it only means that hydrogen is actively degassing in this area, so which is good for us, which is the sign, very good sign for us. So we know about such locations here in Western Australia and on other continents as well.
What methodologies do you employ to quantify the potential for hydrogen leakage during exploration?
Well, first of all, we talk about seeps, not leakage. Leakage is a technical term for something, some unfortunate events. Okay,
Yeah.
so to name a few, we employ several methods, time proven. As I mentioned before, we developed as a group. We developed some of them. We employ other techniques and methodologies borrowed from different domains. So we use soil surveys and soil sample headspace gas chromatography for starters, in order to start working on the surface. Then we also employ satellite imagery, believe me or not, drone based gas detection, radiometry, soil pH, waterborne monitoring. And after we're finished with this initial um, geochemical phase of our field research, we switch to geophysics. And I already told about geophysics. And after that, we're prepared to spot the well consciously.
What technical challenges do you face during drilling for natural hydrogen?
Well, for now, same as in oil and gas industry, really. Like I said, 100% of companies drilling for natural hydrogen, they contract drilling companies from oil and gas. It's no different. There will be technical challenges and the need for some modifications and alterations of those technologies in the future. But with all the talent accumulated and all the competences accumulated by the petroleum industry through the decades, it will those issues will be resolved quite fast. We are very optimistic about that. So to name a few, there will be hard abrasive formations to drill into, because the wells are going to be drilled into crystalline basement, not just in the in not in the sedimentary sequences, in sedimentary cover, regolith, we name it in Australia. Low pressures, production pressures, because, like I said, hydrogen don't form pressurized deposits. Sorry, guys. And if we find one, it will be a huge lag, but it will be depleted and brought down to just above hydrostatics before long.
Yeah, but
Lack of flow when hydrogen is stabilized in the fractures. Hydrogen degassing volume fluctuations is another factor, because it's proven that it fluctuates, comes and goes. But this could be equalized by smarter development models. All right. Potentially, casing strings and other metal equipment embrittlement might be an issue, especially in the long run. So at some point, we need to start thinking about alternative material selection. Something,
mhm.
you use different
Yeah.
materials in for the casing strings and so forth. Water-based drilling fluids have to be used with caution in certain environments. This is my favorite, because in some areas it induces seismicity. Once again, we answered this question as well, but it's a long journey. Okay, maybe next time. But water-based fluids should be avoided in some certain environments.
So what you're saying does make so much sense. How do you
Thank you.
how do other gases affect your exploration efforts?
Mostly the cases, other cases, other associates don't really impact the exploration. Uncertainty of percentage of hydrogen and flow rates do affect the financial planning stage, because we at the beginning, frankly, we cannot say how much hydrogen we're going to obtain on the surface before we start, because in oil and gas, these things are done after the proper exploration phase, like if desktop study, and then surface exploration, and then geophysics, seismic. In natural hydrogen, for some reason, things are expected to hang on the trees for free, and the explorationists like us are supposed to say from the beginning, without leaving the chair, that we're gonna get so much hydrogen for so many years, so many cubic meters or kilos per day, which could be sold for such and such, and here is the profit. Okay,
Yeah.
no sir. And
Investors are spoiled, I know.
well, on the positive side, we have helium quite often as associate. On the negative side, we have CO2, H2S, sulfur, and radon, which is radioactive gas. And nitrogen and argon are common associates, but they are neutral. Nitrogen is
Mhm.
nothing.
You mentioned previously oil and gas. How does historical oil and gas data inform your exploration strategies?
Not much, really, honestly.
Hmm.
Signs of hydrogen sometimes could be obtained through studying the old well records, but there are two downsides. Number one, they are accidental. So they are ad hoc and not expected, and we can't really build the model based on those accidental finds of hydrogen in the past, historical ones. Besides, the second thing is that natural hydrogen, had been ignored, avoided, and not unnoticed for many decades. So in 9 cases of 10, it wasn't recorded because the operators wouldn't really need it. And so it would be quietly siphoned off and then made part of the mix, and transported, sent through the pipeline to the gas plant somewhere nearby. So there was not so many notices, not so many notes and reports about natural hydrogen, especially that not so many rigs were really equipped with the gas chromatographers, and those which were, they had hydrogen as a carrier gas. So you can't really test hydrogen with hydrogen as a carrier, as a media in inside the chromatography. So this is the way it is. Mining minerals, boreholes are equally important because you can always study, if you know what to look for, you can always study alterations, mineral associations, and so forth. Core and chips coming out from the oil and gas wells are very important. But those records are not always reliable, and we use them when we can get our hands on them.
How do regulatory frameworks impact your exploration plans? Actually, I think Australia is known for having regulations for natural hydrogen, at least under the mining law. And like globally, there's no so many countries that do regulate this.
Well, in Australia, things are different for different states. South Australia was the first to adopt their legislation to recognize natural hydrogen as a resource. I'm based in Western Australia, and the things are quite slow here. In other states, Northern Territories, and I believe in Tasmania and the New South Wales, they also recognized hydrogen, mostly under the petroleum legislation umbrella. In some countries, though, it is recognized as a mineral for some reason. I believe several countries in Africa do that. I did that. In the United States, you don't really need the license. You buy a parcel of land, a farm, and you do whatever you want. Well, in very simple terms, provided you don't breach any legislation, local or state or federal. So and everything down to the earth core belongs to you. So it's probably the best jurisdiction for any startup working in natural hydrogen. And the exploration, development, planning, and activities are sometimes severely impacted by the over regulation, by too much of regulation, and the bureaucracy burden may strangle any new initiative in the cradle, as it's well known, not just in natural hydrogen, any industry. So,
Yeah. What specific geological factors will determine the economic feasibility of natural hydrogen extraction?
okay, well, it's a very long story. We employ about a dozen and a half data sets from different domains of geoscience. And we analyze them, synthesize them, and natural hydrogen needs to be found as close to the surface as possible. So we could extract it drilling the wells as shallow as possible. This is the key. So far, the concept of oil and gas algorithm, drilling oil and gas wells for natural hydrogen is prevailing, as I mentioned earlier. But there is an alternative model, harvesting, which means collecting hydrogen from the surface, drilling quite comparatively shallow wells, a couple 300 meters, maybe half kilometer, 500 meters. And this will require the methodology and technology adoption, but it could be an alternative, quite feasible model way to produce natural hydrogen on the surface as well.
Interesting. How do you anticipate government policies will evolve to support natural hydrogen? And actually, will they, say, in next 5 years?
Well, hopefully it will evolve slowly. Depends on the number of factors, and it really depends on the country. Okay, depends on the political system, economical system, and a number of other factors. And lots of factors are involved, are come in play. Some of them are not really friendly. Every government have their own agenda, and natural hydrogen being covered by several legislation facets may become a winning card, or it may become a bargaining chip, or it may fall victim to some certain policies. We never know. It's really it boils down to the people.
Yeah.
The people elect their governments. People elect the authorities who rule the country, their countries, relative countries, and these authorities, they make laws. So
Yeah.
is that.
So back to the technology, what advancements in extraction technologies do you believe would or could significantly impact the competitiveness of natural hydrogen? Is there anything
Well,
technically?
the exploration development processes need to be streamlined and standardized, and not written in stone. It's never written in stone. There, of course, because there are several scenarios for each industry, and those scenarios are flexible indeed. But currently, we live in the era of wildcatters. The same way oil and gas was built about 120, 130 years ago at the turn of the last century. And this is what we see, on the global stage. Every single company entering this natural hydrogen domain, they seem to have their own model, believe me or not.
Mm.
So when we approach some of them, saying, we have 50 years of experience, they say, thank you very much, we're fine. Okay. Some of them learned about natural hydrogen the day before, or maybe the week before. Nonetheless, okay. Well, this is once again, this is what people do or don't do. Um, Technology-wise, drilling multilateral wells will be required, like fishbone or crowfoot. Completions design will need to be altered, modified, especially lower completions. Drilling fluids, I mentioned that. Oil country equipment and off-taking infrastructure indeed. And natural hydrogen has a huge potential in the area of autonomous off-grid power generation because, like I said, it is likely to be found almost anywhere, everywhere, and locally on a small scale. The farmers, the communities could produce electricity independently for them, which is not going to really be liked by the power monopolies.
Yeah, that's definitely for another one.
Yep.
But potentially the debate or a panel. How do you foresee the impact of public and private investments on research and development of hydrogen, natural hydrogen, and exploration?
Equally important, of course. You can't do anything without the cash flow. So,
Yeah.
so wherever it comes from, these cash flows are different from the private equity sources and from the government sources. Um, they're equally important, provided the competition is fair, which unfortunately doesn't happen too often, and the mind openness accompany the process of distributing this investment. Okay, if you know what I mean. Unfortunately, R&D grants are distributed among the mainstream academia, separatization and the likes, with little results so far. And so we see we call it a war of concepts
Mm.
because with a modern official formal science, alternative concepts are not really welcome. Okay, we see it when we try to publish our papers in the scientific through the scientific journals. They get rejected 3 or 4 times before we find the journal with courage, enough courage to publish something new, something like that.
So basically, the concept that finds hydrogen first and makes significant result will prevail. Am I right?
You are right to the point. If hydrogen, natural hydrogen, is discovered, if there is a commercial discovery, well, honestly speaking, it doesn't really mean. It may not necessarily mean that it was found using some certain concept. Okay, we claim we use our concept day and night, but there are a lot of companies who say they use some sort of a concept, but from what they're doing it's not really obvious. Okay, they seems like some of them really employ multiple concepts or models, whichever works first, and then they will try to explain it if they find if they make the commercial discovery. So in the academia domain sphere, we see a lot of attempts to circumvent Dr. Larin's concept in order to arrive to the same conclusions, but somehow without mentioning his concept. Okay, this is what they don't really want, but they like the results, they like the outcome. Okay, so in the process of finding the explanations for the results of their scientific research and lab experiments, sometimes things get really funny, absolutely funny, and we have a lot of joy and fun watching and reading this.
So is it just because it's not so popular to have Russian solutions these days, or in general people like to say that it's their concept or whatever?
I wouldn't really attribute it to some nationalities or race or anything, a religion. No, no.
Yeah.
This is the way the nowadays academia is structured. There is a mainstream, and in geoscience, unfortunately, new data arrives quite slowly because it depends or greatly depends on the instrumental technologies development. Okay, in nuclear physics, for example, there is no such thing as dogmas because
Hmm.
they learn something new every day and they don't have time to dogmatize the concepts they work upon. So if the concept doesn't work for nuclear physicists, they throw it out immediately because it's
Yeah.
staying in the way. It starts irritating them immediately. It's a sore in the eye. Okay,
Yeah. Yeah.
in geoscience, it's it's fine. Like I said, nobody really was back there and back then, so it's impossible to prove anything. So things are fine. We get the grants. We pay our mortgages. So why should we bother?
Mm.
So there is a mindset which is quite common among the modern formal mainstream academia, and they don't really like to see anyone bothering them, disturbing the picture in front of them, trying to push them out from their comfort zones. Okay,
Yeah.
so this is this I might, and this is not just about Russia. In Russia, the Dr. Larin's concept was very unpopular for a number of decades, several decades, until the Academy of Science got some bright-minded academists in mid late 1980s, and they started paying attention. And eventually, just before the Soviet Union collapsed, the Soviet Academy of Science made a decision to support Dr. Larin's concept research through drilling the extra deep well near the Baikal Lake in eastern Siberia. But then the rest is history. Okay, the Soviet Union collapsed. It's never been implemented. It was implemented 30 years later in Nebraska.
Yeah.
All right.
So, what interdisciplinary collaborations have proven essential for advancing your understanding of natural hydrogen systems, and how do they enhance exploration outcomes?
Oh, there are multiple examples of that. I mentioned nuclear physicists, neutrinos. I mentioned astrophysicists. With the new telescope, Hubble, no, Chandra telescope, flying out there on the orbit, which with much better resolution, they start the astrophysicists start obtaining more and more images from very distant and dark corners of the universe, which constantly challenges their existing models. And once again, this is my business partner, Nikolai Larin's hobby. He keeps watching that space for the news, and every time something arrives, he starts rubbing his hands and saying, "Hey, you see, this is it," because they cannot explain it, and sometimes they come with, like I said, we have a lot of fun with it because sometimes they come with the do ex machina, God from the machine. Something happened somewhere, and this affected this and that. And the whole story is very multidisciplinary for us, for natural hydrogen explorers. Okay, for our exploration campaigns, we use dozen health data sets and from different domains, mostly from geoscience, like geochemistry, geophysics, tectonics, structural geology, mineral systems, and alterations, geodynamics, geomorphology, and so forth. Satellite imagery, I mentioned that it's a great aid, especially at the early reconnaissance stages, phases of the exploration program. We employ time-proven field exploration methods customized to the hydrogen's physical and chemical properties because we humans will know a lot about hydrogen since 1766 when it was discovered by Dr. Cavendish in the UK. Well, in England back then. All right. The only thing we would like to prevent is to avoid is copy pasting. A lot of researchers attempt to copy paste the existing algorithms from, say, oil and gas, or from minerals, from other domains, and it's not going to fly because hydrogen is different. It needs so it's a new commodity, new resource. It requires the new approach. This
Yeah.
is it. So this is probably a nice conclusion to our conversation.
Yeah. Vitaly, thank you so much for this exciting conversation. It was very, very interesting.
Pleasure. It's been. Thanks for having me. Thank you very much. Thanks, Aaron.
For sure, we will have another one because I feel that next year will be very interesting in this field.
Hopefully so. Fingers crossed. Let's see what happens.
Thank you.
Thank you very much.
Looking to amplify your brand in the hydrogen energy sector? Welcome to H2 Energy News, your go-to platform for impactful industry insights. Every month, we connect with over 80,000 visitors and generate more than 251,000 page views. Our reach is unmatched with over 1.2 million web impressions and a loyal social media following of 9,000 plus. Our newsletter reaches 77,000 plus subscribers, decision makers, industry leaders, and innovators. Want to target specific markets? Our geo-targeting capabilities cover Europe, the United States, and the MENA region. We reach key stakeholders, 27% senior executives, 32% directors, and 20% owners and partners. H2. Energy News isn't just a news platform, it's where the hydrogen energy community converges to shape the future. Join us and let's make an impact together. Visit energynews.biz and take your brand to the next level.